Okay, welcome back. So today I'm going to talk about mirrors and reflections. They're a very big part of what allowed me to break Tesla's 369 code and to look at the etheric lattice, which I will refer to as the 33 lattice. So I want to get into that, and I think what I can do is certainly help you see as you go through the book this section, and it's really not that complicated. And I can share with you those operations. So I'm going to show you some fundamental mathematical operations with the numbers and then relate them back to the actual um, the grid and the lattice. So let's get into this. I'm going to share my screen, get up my PowerPoint presentation. So just give me 1 second to pull that up. Okay, so now I've got the screen being shared. Um, and so, because this little section deals with mirrors and reflections, everybody's pretty familiar with what a mirror is and how you can see your reflection in a mirror. I've got a couple pictures here so that you can kind of get the idea. One has water, and you're seeing the reflection of the sky with the clouds. Um, Mirrors you might look at when you're getting ready to go somewhere. So when I talk about me, I'm going to be talking about mirrors and reflections quite a bit with the utilization of numbers. So let's kind of look at what mirrors mean and how they going to reflect the numbers, the geometry that I've been looking at. So when you look at a mirror, you really are creating like two orientations of the same pattern. I like to think of it like a coin with the heads and the tails. These are two different orientations, but it's the same. It's the same coin. Throughout the Tesla 36 code, um, the book, I do talk about what's called mirror subtraction and also mirror addition. So I want to look at what those are, what those mean. And these are actually well-defined mathematical operations. So when you see me using these, they're not random and they're not random at all. So where this leads using both the mirror addition and subtraction, it will take you to the 363 scalar circle. And of course, this is different than the Euclidean geometry where we have a 360-degree circle. I have am using a different coordinate system at 363 degrees. So we'll talk more about that. And through the mirror subtraction, I identified you can think of them as a family of numbers, but the family of numbers, they're harmonic. They're going to be called the 1089 harmonic shells. And they're very fascinating, not only from a number standpoint, from a harmonic, geometric, whole number uh, perspective. And then this led me to the what I refer to as the 33 lattice, which is you're going to see is the actual structure of the etheric grid. So when we look at this, there's basically, I'm going to introduce two principles for mere subtraction. So this, what is mere subtraction? So this is where you're going to take a number, and you're going to write its mirror, and you're going to subtract the two numbers, and you're going to keep doing this through an iteration. I'm going to give you an example of this so that you can actually follow it with a number. And when you do this, what I've noticed, two things happen. When you do the mere subtraction and you iterate it, one thing that can happen is it can collapse. Basically, the numbers can collapse to zero, and you will not get any recursion. And I would say at this point, this means there's no longer a cycle. and it will fall out of the lattice. Then, so most of the numbers do this, so you'll see an example of this. The second one, which was the most fascinating, is with the coherency. This is where, when you do the mere subtraction, the numbers enter what I'm going to say is the 1089 family. And you will see that there is a cycle associated with this, and there's coherency with this 33 lattice. So these are the two kind of outcomes that are possible. So let's take a look at the very first outcome. So I mentioned here that if you take a number, you'll see that it can collapse to zero. So the number I selected is just 2,100. So this is the number, and I'm subtracting it from this is its mirror. So you can think of these as being two different orientations, or so you have two different orientations or configurations of the same resonant pattern. When I subtract the two, you can see that I'm going to get this other number that's 2088. And when I go through this operation, no matter what number I get here, I always take what's called the absolute value, which just means that the numbers are always going to come out positive. So here's the rule. You take the number, you reverse it, you subtract it, take the absolute value, and then you repeat this and you see what happens. So you can see in this first one, we go to 2088, and then I write this number over here, and then I minus it by its mirror. So its mirror or reflection means the same thing, 8802. So that's 8802. I get 6714, and then I take 6714, I minus it by its mirror, 4176. We get 2538. I do that again. And I minus it by its mirror, which is 8352. I get 5814, and I keep doing this. 5814 minus 4185, I get 1629. And so as I go through this, and this is a relatively long iteration, most of the numbers will have resolved by this point. This is a very long, I think it goes through like 12 iterations. And then it ends up down here where it goes 99 minus 91 or zero. So in this case, 2100 collapsed to zero. So it did not go into a cycle. And this would be that it would be falling off or out of the lattice. So it doesn't sustain what I would say is a recursion. Recursion is where you will see a repeat, like a repetitive nature, cycling to it. But this one actually dissipates, the pattern dissipates, and you could say that it folds to zero. And again, just to reemphasize that these two numbers, when you do the primary number here and its reflection are representing two different orientations. And you can subtract those two numbers. And so you can get a phase, if you want to think of these as kind of phases, you can get a phase differential between those two specific numbers. And also measures the amount of asymmetry between a number and its reflected form. And also in terms of, say, wave terms, if you want to think of wave terms, it represents the out of phase component, which is basically what doesn't align between the two states. I wrote this out here so you can just kind of see this as it will fold into this zero here as you see it go through its mirror. So this is mere subtraction. Now this is the collapsed to zero, or you could say it's the fold to zero. You know, I think using these terms collapse or fold to zero, I will use the term fold sometimes when the geometry will fold and then it will refold back out. And so normally when I use the word collapse, it means that it's not going to refold back out. So here is the very first outcome. So let's go to the second outcome. Now, this is what was so fascinating. Okay, so here's an example of a number, and this one is 1232. So if we put 1232 through its, and we minus its by its reflection, it's 2321. You get 1089. Okay, now if you've read the book or been in the book, you know 1089 is a very important number. But let's say you didn't know and you took 1089 and you subtracted it from its mirror. It goes to 8712. And then 8712 minus its mirror, 2178, gives you 6534. 6534 minus its mirror, which is 4356, is 2178. And then 80, if you take, well, this should have been 2178 minus 8712, it would give you 6534. And then you can see we would get 6534 minus 2178. We get 4356, and then minus 6534, and we're back to 2178. So we're in this kind of this loop here that you see here. And so this is like a cycle. So in this instance, 1232 is not collapsing to zero, but it's demonstrating coherency. And this is what was incredibly important and different from the first outcome. So when I saw that, I actually working with another individual and Lauren Kim, then she worked together to write a custom script in R where we basically systematically search for all numbers up to 100,000 that wouldn't collapse to zero under iterated mere subtraction, and we generated this list of numbers. And it took me a little while to go through the numbers and recognize the specific patterns, but I did find a pattern of numbers that became known as the 1089 multiple family. And it's these numbers. What does it mean to be the 1089 multiple family? Is this connected to the geometry? Why do these numbers, why are they coherent? Why do they cycle? Those were all big questions. So here are some of the numbers. These are the numbers that came out of looking at that data set. I found that all of the numbers would actually go into this cycle, and I found 1089. I found 9801. These are mirrors of one another. I found 2178, 8712. This is another mirror pair of the numbers. These are all 1089 multiples, like 1089 times 1, 1089 times 2 is 2178, 1089 times 3 is 3267. Then I found its mirror, 7623, which is 7 times 1089, 4356, which is 4 times 1089, and then 6534, which is 6 times 1089. These are four mirror pairs, and this was incredible that I saw that these were coming out. It's like a harmonic family, and then one other number, which is 5 times 1089, is 5445, and it doesn't have a mirror pair. This is what I'm going to refer to as the inversion axis. You can think of it as the inertial stiffness node when I show you the actual lattice. So it's the center of the lattice, the still point from which all mirror shells are going to emerge and return. So in summary, in here, what I found was in the numbers that were not collapsing, the numbers that were able to go in this cyclic loop, if you will, there were four mirror pairs. These, you can think of these as vortices, one inversion axis, and these are known as the 1089 multiples. And these are nodes on the lattice, and I'm going to show you the 33 lattice. They're actually going to be nodes on there. And if you look at the nodes, if you are below the inversion axis, which is the 5445, an example of this would be 2178. It's magnetic, and those that are above it are dielectric. So you can see this is actually a mirror and a mirror pair that you're seeing here. Um, so you can also think of this as scalar breadth as 2178 being magnetic, and being the exhale, and then 8712 being the inhale of the same actual breath. Uh, Here's another way to kind of represent this. I put these as vortices. You can see here, just representing these by circles. 5445, you can see this is in the center here, so it's symmetrical. So you have 1089, and then it's mirror 9801, 2178, and it's mirror 8712, 3267, and it's mirror 7623, and then 4356 and 6534. And all of these are all divisible by the number 33. Okay, so these are rings of coherence that are formed by doing that. You have recursion, and you can see these are all like the multiples, almost like you're looking at steps, dimensional planes, if you will. And there were 9 of them. Now, the interesting thing too about one of them is that one of the 1089 multiples was incredibly, it was very interesting. It was 2178. All of the 1089 multiples would actually fold to 2178. So this in mathematics is when numbers do this, they're known as attractors. Everything was converging to 2178. So I just here just to show you here, 1089 minus its mirror goes to 8712, 8712 minus 2178, 6534, 6534 minus its mirror, you end up at 2178. 2178 minus 8712 is 6534. 6534 minus 4356 is 2178. And you can see as you go through each individual 1089 multiple. Now think too, these are ultimately geometric as well. So I'm showing you them as numbers, but as we're putting these through these mere subtraction or mere reflections, the iterations, you can see there's recursion, and you can also see that we have cycles or loops going on here, and this happened for all of the 1089 multiples. Look at this. So you can see already that 2178 is a very, very special number. And I'm not going to go into it here in this video, but this number shows up in certain locations on the planet, and it's mathematicians have worked on this number, not knowing exactly what it's doing. Just have worked on it, but this number is playing out here in the mathematics, and is the second shell, and you can see I'm saying it's acting like a local attractor, because the other 1089 multiples on iterated mirror subtraction are actually being attracted to that specific number. And if you look at the hourglass, remember last video, I used Nikola Tesla's vortex mathematics, the doubling and halving of numbers, and I put the numbers onto the hourglass, where we took 1 and doubled 1, and we got 2, doubled 2, we got 4, doubled 4, we got 8, doubled 8, we got 16, or that was a digital root, 1 and the 6 and the 7, and we doubled 16 and got 32, and that was 5. And then the whole thing repeated again. And so the forward flow of energy here, you see And then if you run it backwards, you half the numbers. You take one, divided it by two, you get zero point 0.5, and then and so forth, you go backwards. So I showed that in another video, and I showed you how I put the 3, 6, the 0, and the 9 on here to form what looks like the Great Pyramid. If you pull up this constriction point here, right here, which would be like this, the null point. But if you were to break this apart into two, where it's like symmetrical, but right down the seam, you'd get the 2178. So this here, you get 2178. On the other side, you get 2475. And you can see if you put 2475 and you put it through iterated mirror subtraction, you end up with 2178. So we're back here. So this was actually, when I saw this, I knew 2178 was an important number, an extremely important number. So let's then look at the etheric lattice. How do we connect this? How do we bring these numbers, the 1089 family, into a grid? So I'm going to show you a repeating numerical grid that are formed by multiples of 33. I introduced this in the last video that I did, because this is connected with what I was calling Tesla's etheric lattice. So I'm going to call it the 33 lattice. And this defines stable harmonic nodes. And so I introduced this the last presentation I gave. So this is what looks like 3 concentric rings. And this is only part of the etheric lattice. I'm only showing you one triad. And you can see there are 1, and there's 2, and there's 3. So this is the circle here. I'm going to refer to it as the 363 scalar circle. But if you look here closely, there within the circle, I have divided it by using 11 radials here. And then at each one, these are nodes. So in here, the first one here, I'll just define this at this point. This is the singularity right here. This is 33, then it goes to 66, 99, 132, 165, 198. So these are all increments of 33 steps, like Jacob's ladder. It's very interesting on some of the stories, that biblical stories, myths. You find lots of connections with this etheric lattice. So it goes around here. And then once you go around here, you get to this last one. 11 times 33 is 363. So this is one rotation around. And then you pick up over here. So this is the 12th node, 13. So this is going to go then from here, 11. So you have 11 nodes in the first concentric ring, and then you're going to get 11 more here, which will make 22. And then you'll get an 11 more out here, which you'll then make 33, ending here at this point. So all of these nodes, I've shown the ones that are incredibly important, that I was just like highlighting. 363 is the scalar circle. 726 in my mathematics is the tetrahedron, and 1089 is the square base pyramid. So this is actually, this node here is 33 times 33. It's 1089. And if I was to keep going out and adding more rings, you will see that 2178, 32, 67, and 43, 56, they're all those 1089 multiples are going to fall on the same radial, which is very fascinating because these geometric structures here can fold from one to the other. We'll talk about that a little bit later. The other thing that's interesting here, so what I'm doing here is just connecting the etheric lattice, this 33 lattice, to the 1089 multiples. It's also, if you digital root these, so if you take 33 to a single digit, this is 6, this is 12, or a 3, this is 18, or a 9. When you take these two numbers and you take them into a single digit between 1 and 9, you see that it's 6, 3, 9, 6, this will be 3, 9 as you go around here. So this is consistent with the 3, 6, 9 that Tesla was talking about. And just so you can see here, the Euclidean geometry that's actually at 360 degrees and the new scalar geometry, different coordinate system. Geometry hasn't changed, but I'm using a 363-degree coordinate system. In Euclidean geometry, you can see, I just listed some of these so you could see the tetrahedron. These are internal angle summation of the angles for these polyhedrons. So this is a tetrahedron. It's 4 triangles, 720 degrees. Octahedron, 1440, cube, 2160, icosahedron, rhombic dodecahedron, and the pentagonal dodecahedron. So I'll go into these in a separate video and show you how to calculate the internal angles of these geometric shapes. And the reason why this is important because it tells you the magnitude, it tells you the container and how much magnetism that can be packed in there. But then over here, you can see in the scalar geometry that we have 726. This is shifted by 6 degrees relative to the Euclidean geometry. And then I have 1452. This is the star Merkaba. In my system, 2178 could be an octahedron. It's 2 square-base pyramids put together, 1089 times 2. The rhombic dodecahedron, that's 1089 times 4. And then the pentagonal dodecahedron is 1089 times 6. So just to give you an idea of those 1089 multiples you're seeing here pop out, they're also relating to geometric structures as well. Okay, so now let's talk a little bit about, instead of talking about mere subtraction, I'm now going to introduce mere addition. And this is just where you take the number and its mere and you just add them together. So this is an example of 891. This is a reason I picked this was because Nikola Tesla's room number was 33 times 27. 33 times 27 is 891. And then if you add its mere, you get 198 or 1089. So what does it mean when you're doing mere addition? This just basically means that this reveals the return basically of the system to unity, where you have the recombination, and you're recombining 2 mirrored orientations into a single harmonic identity. Another way to put it, these are 2 mirror forms. You're putting them back together into one unified structure. So this represents the inward return, the dielectric return, or this is this part of the scalar breath, the return. I talked about this quite a bit in the book. I talked about the exhale, and then which is magnetic and expansion, and this is dealing with the dielectric return. So really, mere subtraction is dealing with magnetic expansion. And here, mere addition has to do with the dielectric return. So this closes the loop, closes the cycle, brings the system back to its harmonic family. And so it moves it back toward the phase lock and symmetry. And also, you see it's integrating the magnetic and dielectric orientations into a single coherent state. So this is kind of what you get when you're doing mere addition. Now, because sometimes people would say, "Oh, I'm not sure you know what you're doing with these numbers. Is this?" I've already said it was mathematically valid, and the mathematicians use this. But I wanted to give you an example for kind of chemistry, because this you see in chemistry, this is kind of an analogy between chemical structures and the numbers. So I'm treating them like mirrors. So in chemistry, there's something known as an enantiomeric pair. This is where 2 molecules, they're basically mirror images of each other. And these molecules have the same composition, that is the same atoms that make them up, the same connectivity, but they have basically, they're oriented in opposite spatial directions. We refer to these in chemistry as left-handed or right-handed. So I made this little example here where we can have the same molecule, same atoms. This would be like having the same number, same digits, the mirror image. Then this is equivalent to taking the numbers and reversing the digits. So this is the mirror orientation. In chemistry, you have left-handed and right-handed. In our system, magnetic versus dielectric orientation. All right, in chemistry, they have the same identity but different behavior. And over here we have the same structure but opposite orientation. So this is just to show you here when we're using numbers in the mirror. So here's 2178 and here's its mirror 8712. So this is the number and its mirror. Over here, this is just a particular molecule in chemistry. There's a carbon atom at the center. There's four different substituents attached to them, but they're all the molecular formula are identical between these two. But these are known as isomers. An enantiomeric pair is an example of an isomer. This one is just the L form, and this is the D form. So I was just using this as an example to show you in nature has mirrors as well. So I was just using the numbers to give you that example. So how can how can we use a 363 scalar circle? People are like, no, you can't do that. We're using a 360-degree circle. And so a lot of people raise their eyebrows at that. But I'm telling you, the geometry doesn't change it at all. Coordinate system does. As you recall, 360 degrees. This system here measures position in space. It uses rational and irrational numbers. The 363 system measures phase relationships within a structured harmonic lattice. And I was showing you that lattice only uses rational numbers. It's not using irrational numbers. And so this is a different measurement and interpretation system. I tried to summarize the mirror subtraction and addition, so you can actually see mirror subtraction is where we're having basically separation. This is magnetic exhale. So this is separation. We're subtracting the two numbers from one another, and so it's a phase differential. It deals with motion. There's amplitude involved, expansion, projection. These are just terms that describe like magnetism. Mirror addition is where we are adding them and you're having the reunion or the unity here, return back to the singularity, closure, integration. So mirror subtraction reveals motion. This has to do motion around the lattice. Mirror addition restores the unity. Together, they both describe the full harmonic breadth of the system. So, really, why does this matter? The mirror, if you look at the mirror subtraction, it reveals coherency, coherent patterns, and it also reveals non-coherent patterns. So the 1089 multiple family, this is the coherency. The other ones numbers are not coherent. It identifies the stable harmonic geometries and describes the motion and the return in scalar systems. So I hope this helps you understand a little bit more about when we're looking at mirror subtraction and mirror addition and those operational procedures that are occurring and how you can use it to actually find coherency within the numbers that were also reflecting the geometry. So look for and tell other people to subscribe as I add more and more videos here. I will, everything will start interconnecting and it will help you get through the book and help you understand this incredible like hidden system that is clearly connected to free energy. Okay, with that, I'm going to tell you goodbye and I'll see you next time.